This is part 2 of lesson 2.1.2. So far we already went over slope. Slope is the same as steepness. A hill can be going up, a hill can be going down, a hill can also be horizontal. And if you're really crazy, you could be climbing a mountain that has a steepness of, well, this isn't 0. This is actually, in math, the slope of this one is, what's it called if it's vertical? Yeah, it's also called undefined. That's right. So we've been going over slope. We've been going over topics including the y-intercept. We have the equation of all lines, which is y equals mx plus b, where m is the slope and b is the y-intercept. So we're going to be finishing up lesson 2.1.2, so can you go ahead and make sure we're going to problem 2-14. So find this in your packet. We're going over 2-14, and we're going to finish this right here as well, just to check our work and to make sure that we have the correct answers for these problems, preparing us for any upcoming quizzes or tests. So 2-14 says the graph at right shows a linear model. What's a linear model? A linear model is a line. You draw a line that graphs, well, a model would show you that it really should be dots, but when you connect the dots, it creates a model for its growth. A linear model for a tile pattern. How is the line growing? That is how many tiles are added each time the figure number is increased by 1. So explain how you found your answer. So how much is it growing each time by 1? What is it growing by? The real way that we want to tell this is going to be looking at the numbers that are given to us. We have the change in y, which is 27. It's a vertical change. It's going up by 27. And we also have the change in x, the horizontal distance. Change in x is 3. So if we simply know that this is called rise 27 over run 3, what is rise over run? Write this down. Rise over run. Up 27 over 3. What do you get when you divide those two numbers? Yeah, you'll get 9 over 1. You'll get 9. The slope is 9. Explain how you found your answer. 27 divided by 3 is 9. So we know that it's growing by 9 tiles each time. Problem 2-15. The triangles drawn on the graphs in part B of problem 2-13 and problem 2-14 are called slope triangles. So basically these things are called slope triangles, rise over run. Slope is a measure of the steepness of the line. If it is the ratio of the vertical distance to the horizontal distance, change in y over change in x, of a slope triangle. The vertical distance of the triangle is called change in y, while the horizontal distance is called change in x. We're using this Greek letter, which looks like a triangle. It says, note that the change, or delta, is the Greek letter that is often used to represent a difference or a change. So real quick, let's just answer these questions A, B, and C based on the graph that's given here. What is the vertical distance for this slope triangle? So it looks like it's going up by 2. Change in y is 2, which you can also count vertically this way. 2. And what is the horizontal distance? That is change in x. 1, 2, 3, 4. You can also count it this way. 1, 2, 3, 4. So what would the slope be? Right? Let's write this down. M, which is slope, is change in y, which in this case is 2, over, yes, not change in x over change in y, but change in y over change in x. So if you did this correctly, you got 2 over 4, which is just a fraction. A fraction is the same as division. So if you simplify this fraction, dividing the top number by the same number as the bottom number, if you divide by 2, cut them in half, you will get your slope as 1 over 2. Now check this out. How crazy is this? 2 over 4 is the same as 1/2. Do you agree 2 over 4 is the same as 1/2? Yes. So if we look at the triangle 2 over 4, look at the slope triangle over here. 2 over 4 is the same as 1 over 2. 1 over 2. If you follow that, you'll get the same slope, because 1 over 2 is the same as 2 over 4. All right, very good. If you got that one nicely done, let's go ahead to the next one. It says draw several smaller slope triangles for this line that have a change in y of 1. And we also got the same answer. The slope was 1/2. 1 over 2. 1 over 2. Okay, let's turn over. It says, what is the equation of this line? Well, we have y equals mx plus b. What was our slope? Our slope was 1 over 2. And what was our y-intercept? Let's look over again. If you have this right, the y-intercept crosses right there at that number 2. Right there. So it's going to be, yes, 1/2 x plus 2. That would be the equation. Box that answer, please. Okay, next problem, 2-16. Answer the following questions for the line graphed at right with slope triangles A, B, and C. Calculate the slope using slope triangles A and B. What do you notice? So as you can see, slope triangles can be drawn below the line. I typically like to draw it above the line, because what is slope again? Rise over what? Right, rise over run. So if you count this, you can get 1, 2, 3, 4, 5, 6 over run. 1, 2, 3, 4. So slope triangle A, we have 6 over 4. What about slope triangle B? The rise is 3. The run is 2. What do you notice about both these numbers? 6 over 4, 3 over 2. You can say they are equal. Letter B. What is the vertical distance of slope triangle C? The vertical distance is 1, 2, 3, 4. Looks like 4.5. You could say looks like 4.5. You could put a little question mark. Explain your reasoning. That's a weird one. Our next question says, draw a slope triangle of the line. By the way, 4.5 might be incorrect, so just we'll leave it there, right there. So letter C. Draw a slope triangle on the line with a horizontal length of 1 unit. What is the vertical length? So this one's saying we want to have horizontal length of 1 unit. What would that look like? We can draw it anywhere on our line, but we want to have a horizontal length of only 1 unit. So what would be the vertical length? Looks like it's about 1.5. Again, a vertical length of 1.5 over 1, 1.5 over 1 does seem to be accurate for this one. So what do you notice? Well, something you could look at is all these slope triangles should be the same, right? Is 6 over 4 the same as 3 over 2? And is that number also the same as 1.5 over 1? Well, check this out. What is 6 divided by 4?
It's 1.5.
What is 3 divided by 2?
The answer is 1.5.
And what is 1.5 divided by 1?
It's 1.5.
What do you notice? All slope triangles should be equal. Even though they're bigger fractions or bigger triangles, they should all have the same slope. In this case, it was 1.5. Letter D. What happens to the slope when the slope triangles are different sizes? They remain the same. For example, if I had 5 over 2, 5 over 2, what would it be if it was 10? What would it be if it's bigger? Like if it's double, then this should also be double. 10 over 4. If this was double again, to be 20, what would be in the bottom? 8, right? Because all these fractions should be the same. What is 5 divided by 2?
The answer is 2.5.
What is 10 divided by 4?
It's 2.5.
20 divided by 8.
The answer is 2.5.
So as you can see, the slopes, which I said they, remain the same. All right, go ahead to this next page. Problem number 2-17, let's check our work for this one. As you can tell, just right away, you should look at a graph and say, would you want this to be your bank account? Would you want that to be your bank account? Right away, you should say no. I would not want my money to be going down from left to right. So this one, you should notice right away, it should be a negative slope because it's going down. Okay. Michaela was trying to determine, let's read. Michaela was trying to determine the slope of the line shown at right. So she selected 2 points, but you could choose any 2 dots you want, but she chose these 2, where the grid line intersects, and then drew a slope triangle. So where she says where the grid lines intersect, that just means it's called a lattice point. All these little dots right here, where the grids meet, are called lattice points. Can you write that down, please? Lattice points. It's kind of like lettuce, but with an A, lattice, and not a U, but an I. So she chose these 2 dots because those dots are going to give her the most obvious slope. So her teammate drew a, well, it says, let's just read. Her teammate Cynthia believes that change in y is 3. Change in y is 3. Do you agree? Okay. Because the triangle is 3 units tall. While her other teammate, Essie, thinks that the change in y is -3. Because the triangle is 3 units tall and the line is pointing downwards from left to right. With whom do you agree and why? So you could have discussed that one with your team. Actually, if you would like to now, can you please turn to your neighbor and see which one do you agree? Is it +3? Is it change in y 3, or is it change in y -3? So let's just leave it there because there's more to see with this problem. Because you can have your opinion and it's okay. Letter B. When writing the slope of the line, Michaela noticed that Cynthia wrote negative 3 over 4, while Essie wrote negative 3 over 4. So I'll write this a little bigger here. Negative 3 over 4 or negative 3 over 4. She asked, are these ratios equal? Are these equal? Discuss with your team and answer the question. So for this one, the quick answer is negative 3 divided by 4 the same as negative 3 divided by 4? Let's see. What is negative 3 divided by 4?
The answer is negative 0.75.
And this one is the negative version of 3 over 4. What is 3 divided by 4?
That would be 0.75.
So are these equal? Yes, they're equal. So it says discuss with your team and answer the question, are they the same? The answer is yes. Which way would you rather write it? Well, let's go to the answer for the slope. Y equals mx plus b. Sorry, the equation of that line. Y equals mx plus b. So we already know the slope is negative 3 over 4, however way you write it. I am going to go ahead and write this as negative 3 over 4. If you wrote the negative in front like this, that is also fine. And what is the y-intercept? The b is our y-intercept. So what is the y-intercept? Yeah, the y-intercept is at 0,9. So the equation is negative 3 over 4x plus 9. By the way, a lot of people will say 3 over 4 because they're like, oh, 3 over 4. The slope is 3 over 4. But if you ever notice that the graph is going down, ask yourself, would you want to be your bank account? Most people would say no, and the reason why is because it's going down. It's negative. So you have to make sure that your slope here includes a negative symbol. It does not matter if you write it as negative 3 over 4 or negative 3 over 4 because they're both the same answer. All right, go ahead and flip your paper to the next side. We're going to take some notes on the coordinate plane. For this one, coordinate plane, a coordinate system formed by the, write this down, intersection of a horizontal number line called the x-axis. So we have the x-axis and a vertical number line called the, that's right, the y-axis. Very good. So far we have the x-axis and y-axis, and together they form something called the coordinate plane. Points, also known as coordinates, little dots around our graph, are labeled with x and y. Example. By the way, this might not be fully correct because would you also just say, oh, the coordinate is negative 2x and for y? No, you'd say negative 2 and 4. Okay. Ordered pair. A pair of numbers that can be used to represent a point or dot on the coordinate plane, often expressed as x comma y. The first coordinate x of an ordered pair is the value for x It tells you the position on, well, we can just say the position, well, on, let's just write this down this way, on the horizontal axis. The second coordinate y of an ordered pair is the value for y. It tells the position on the vertical axis. We can also say vertical axis or plane, I think. And quadrants, there are 4 quadrants. There are 4 quadrants. Remember, this is called x and this is called y. So there's 4 quadrants. I will label it in 2 different ways. The first way to label it, write this down, is quadrant 1 is here, where it's positive, positive. Positive. Quadrant 3 here, which is negative, negative. And quadrant 4 here, which is positive, negative. Now typically this is written a different way, so you'll see it like this. There are 4 quadrants. We have the first quadrant, which is quadrant 1, and written sort of like that, numerals. Quadrant 2, written like that. Quadrant 3, and quadrant 4, which has sort of like a IV, which means the number 4. So now, what I want you to do is I want you to take some time to flip it over and work on some slope. Find slope using rise over run. Remember, rise is known as the change in y, and run is known as the change in x. So we're going to do a couple of these together, and then I would like for you to do the remaining 6, and then we'll check our answers. So for the first one, this is a little weird to say, but we have a horizontal line here. Just choose any 2 dots you'd want here. I'm going to choose these 2 here. What is the vertical change here? What is the rise? 0. What is the run? 2. So if we divide those 2 numbers, what is 0 divided by 2? What do you get? Right? Try not to guess. Use a calculator. What does it give you? 0 divided by 2 is 0. Okay, next one, letter or number 2. What is the vertical change rise? So choose these 2 dots where it's drawn for you. The rise is 1, 2, 3, 4, 5, 6, 7, 8. And the run is 2. Now, if we divide 8 by 2, what do we get? Yes, 8 divided by 2 is 4. So the slope for that one is 4. Okay, next question. Rise over run. Vertical change, we're using these 2 dots here. 3. What's the horizontal change? Count carefully. You can count the number of boxes that are there. We have 1, 2, 3, 4. So 3 over 4. Okay, the slope of this one is going to be 3 over 4. Leave it like that. You could write it as a decimal if you really wanted to, but you leaving it as fractions does tell you the rise over run. Okay, we're going to do this next one here. What if it's negative? What do you do? Yes, the rise, go ahead and say negative 3. It's going down 3. Rise can be positive or negative, so down 3 is negative 3. And what's the run? Run is always to the right, so it's going to be 4. So this one would be negative 3 over 4. Leave it like that. Now go ahead and try the next ones, and we'll check our answers in just about 3 minutes. Go, help each other out. Okay, number 5. Did you choose any two dots? Any two dots on your graph? What was the rise? For you, you could have said the rise was 2, maybe it was 3, maybe it was 7. Whatever two dots you used, you chose a vertical rise that has a number. For this example, with these two dots here, I have rise is 2. And what's the run? What's the vertical? Sorry, what's the horizontal change? There's no horizontal change. So if we do 2 divided by 0, what do we get? What is 2 divided by 0?
The answer to anything divided by 0 is that there is no answer. So that's my answer. Except it's not an answer. It is, right?
So this one, if you ever divide by 0, you would say undefined. Any vertical line, remember I brought this up earlier, any vertical line is undefined. Next one, check your answer for this one. The vertical change was negative 4. Sorry about that. Vertical change was negative 4. What was the horizontal change? Yes, negative 4 over 3. That can't be simplified, cannot be simplified, so the answer is negative 4 over 3. Okay, let's check our answers for these last 3 problems. What was the vertical change for number 7 here? Negative 2. What was the horizontal change, the run? 1, 2, 3, 4, 5 boxes. Count carefully, because it's pretty easy to count incorrectly. But the correct answer for this one, if you got it, nicely done. It's negative 2 over 5. Okay, next one here. Rise. 1, 2, 3 boxes. Run. 1, 2, 3 boxes. Remember this slope triangle could have been written bigger. We could have drawn a bigger slope triangle, but they chose a pretty small triangle there. And we got 3 over 3. What is 3 divided by 3? 1. Nicely done. So you could have used a smaller box. So 1 over 1, 1 over 1, 1 over 1. You could have used a smaller slope triangle, and that would be your slope. Okay, check your final one here. With practice, you get really good at these. We're going down 2, so it's negative 2. That's your rise. Your run is always positive. 1, 2, 3, 4, 5, 6. Negative 2 over 6. Well, this one, they're both even numbers, so I need to cut them in half. Negative 1 over, we cut negative 2 in half, we get negative 1. What's half of 6? 3. So let's just confirm that we do have the same answer here. Negative 2 divided by 6.
It's approximately negative 0.3333.
Negative 1 divided by 3.
The answer is approximately negative 0.3333.
So the same answer. That means we could have drawn a smaller slope triangle and still got the same slope. So that right there wraps up a lot of our needs for learning slope. I hope that you found it useful, and yes, if you're becoming an expert, that's awesome. That's awesome. Help each other out, because slope with practice can become very, very easy. If you're getting good at this already, fantastic. If you're not, continue to practice, continue to trust the process, and you're going to do great.